Hello everyone, welcome to today's online session. So today we will be dealing with the topic stereoisomerism. So already we have completed few topics from this chapter. So today we will be continuing the remaining topics. So let us continue with elements of symmetry. So what is this element of symmetry? So elements of symmetry are imaginary elements that define whether the molecule is chiral or achiral, or and also this define the superimposability of molecule on its mirror image. So characteristic of these elements of symmetry are it defines whether the molecule is chiral or achiral, and also it defines whether the molecule will be superimposable on its mirror image. So chiral molecules. So what are chiral molecules? Or chiral carbon? The carbon having all different atoms attached to it is said to be chiral carbon and is denoted by star mark. While achiral carbon is the carbon that is not attached to different atoms. Here means it has at least two similar atoms attached to the carbon. This is known as achiral, while this is known as chiral carbon, and this is achiral carbon. So now there are totally three elements of symmetry. Three elements of symmetry. So plane of symmetry, center of symmetry, and alternating axis of symmetry. So we will see individually what are these different axes of symmetry. So let us now see what is a plane of symmetry. So plane of symmetry is an imaginary line that passes through a molecule which divides it into two equal halves. Such that one half of the molecule is exactly the mirror image of the other half of the molecule. So let us see example of such. So if we take example, so here you can see that this molecule is exactly the mirror image of this half of the molecule. So now this imaginary line we have drawn, so this is known as plane of symmetry. So this you can see when we divide a molecule, this is whole a molecule, when we divide it with using an imaginary line, this line divides the molecule into two parts, part A and part B. So you can see here part A is exactly the mirror image of the part B. So hydrogens, hydroxyl and carboxyl group. So exactly the mirror image of each other. So this is known as plane of symmetry. You can also see another example here, OH, C, COOH. This is also one molecule. If we divide using a imaginary plane, we will get again two halves, but these half of the molecules are not exactly the mirror image. You can see even though carboxyl on the same side, but the position of hydroxy and hydrogen is changed. So this will not give a this is not a plane of symmetry. Here this is plane of symmetry, while this is not a plane of symmetry, because the one half of the molecule is not the mirror image of other, while in this case one half of the molecule is exactly the mirror image of other half of the molecule. So now let's see what is the second element of symmetry, that is center of symmetry. So this center of symmetry is defined as an imaginary point in the molecule through which lines drawn on one side and produced at an equal distance. You can see equal distance on opposite side will meet the identical or same groups. So let us see an example for such center of symmetry. So this is cyclobutane, and H. So if we assume that this is a center. Now if we assume that this is a center of the whole molecule, and you can see here CH3, COOH, H and H, while on the below side it is H, CH3 and COH. So you can see here CH3 is upside, while here CH3 is on bottom side, and here COOH is on upside, while here it is on bottom side. So if we now draw, here you can see the definition that lines drawn on one side. So if we draw and meet this CH3 on the one side and produced at an equal distance on opposite side. So here it is up, here it is down. If we produce or extend this line on the opposite side, that is downside, it will meet the same molecule. Similarly here also COH from one side, while on the opposite side it is meeting on the upside. Similarly hydrogens up and down, and this is down and up. So you can see this is how the center of symmetry is defined. That is an imaginary point. This is an imaginary point through which lines are drawn on one side, and if it is produced on the opposite side to an equal distance will meet the same molecule. You can see here same molecule. So now let us discuss the last element of symmetry, that is axis of symmetry. So this axis of symmetry is defined as an imaginary axis through which if a molecule is rotated at an angle of 180 degree followed by reflection, this is important, followed by reflection, will give a molecule which is exactly similar to the original molecule. So let us see an example. So again a cyclobutane. So if we draw or add groups, so Me represents methyl, or also you can write it as CH3. Me is methyl, or you can also write it as CH3. So now let us assume a imaginary axis. So this is an imaginary axis. So if we rotate this at 180 degree, if we rotate it by 180 degree, so we will get so after rotation, this if we rotate to this much, this will give 90. Again we have to rotate up till here, so you will get 180. So this will come this side. So this and this will interchange, while this and this will interchange. So now this we are writing here hydrogen, methyl. This we are writing on opposite side, methyl, hydrogen. Similarly this we will be writing on opposite side, methyl, hydrogen, and this will be writing on opposite side, that is hydrogen and methyl. So now you can see this has come here, while this has come here after 180 degree rotation, and these two have interchanged. So now if we plot its mirror image, so this is A and this is B. So now if we take the B molecule, this is methyl, hydrogen, methyl, hydrogen, hydrogen, methyl, and hydrogen and methyl. Again, same axis. So now if we take its mirror image, so now what will happen? This methyl will come this side. So methyl and hydrogen and methyl and hydrogen, while these groups will be shifted on this side. Hydrogen methyl and hydrogen methyl. So now you can clearly see the configuration of this molecule and this molecule. You can compare these. Methyl and hydrogen, methyl and hydrogen, again methyl and hydrogen, methyl and hydrogen. When here hydrogen and methyl, hydrogen methyl, and hydrogen methyl, hydrogen methyl. So this is how this axis of symmetry is defined. So you have to rotate first the molecule by 180 degree through an imaginary axis to get some molecule B. So now this molecule B, when its mirror image we plot, we get same A molecule with same configuration. So this is how elements of symmetry is defined. That is plane of symmetry, that is an imaginary line that passes through a molecule which divides it into two equal halves such that one half of the molecule is exactly the mirror image of the second half. While similarly for the center of axis, so here an imaginary point within the molecule through which lines when drawn on one side and produced at an equal distance on the opposite side. When drawn on one side and produced at an equal distance on an opposite side meet an identical or same group. This is known as center of symmetry. And axis of symmetry is an imaginary axis through which molecule rotated by 180 degree followed by its reflection, produces the exactly similar molecule as the original one. So these elements of symmetry define whether the molecule is optically active or not. Optically active or optically inactive. If the molecule has at least one element of symmetry. If it has at least one element of symmetry, then it is defined as optically inactive. And if the molecule is not at all symmetric, if the molecule does not show or does not possess any elements of symmetry, then the molecule is said to be optically active. So these elements of symmetry is important to define whether the molecule is optically active or optically inactive. It is also used to define whether chiral molecules will possess elements of symmetry or not. Already we had seen the characteristics, that is they must possess either chiral or achiral molecule, or it must be either superimposable image. So here now if the molecule is chiral and if molecule is achiral, if molecule is chiral then it will have no elements of symmetry, while if the molecule is chiral then only it will possess element of symmetry. So these elements of symmetry can define whether a molecule is chiral or achiral, and also it will define whether the molecule is optically active or not. So these are the two important features to define molecules element of symmetry. So thank you for today's session.